Okay, this lesson is on medians and altitudes. You can see by our learning targets, I can state the definition of a median. So we're going to have some new definitions, and then basically I can apply it in proofs and to solve other kinds of problems. Same thing with an altitude. I can state the definition and use it in proofs and other problems. And then it's really important that we recognize the difference between what a median is and what an altitude is. And then this final target is a little separate. It's an easy one, but it says I can add appropriate auxiliary segments to a diagram. So we'll hit that at the very end. So let's go back to the two big ideas for the lesson, median and altitude, and let's define them. I'm going to start with a picture. So make yourselves a triangle. All right, and if I connect a vertex to the midpoint of the opposite side here, and I divide that into two congruent segments, this segment right here is called the median. So it goes from a vertex to the midpoint of the opposite side. It divides that opposite side into two congruent segments. So here's how we're going to say it. If a segment from a vertex, let's say, divides the opposite side of the triangle into two congruent segs, then it is the median. Now, of course, I could flip that around and say if a segment is the median, then it divides the opposite side into two congruent segs. Okay, so that's a median. From a vertex to the opposite side, divides it into two congruent segments. An altitude, draw yourself a picture again. Let's make the same kind of triangle. Altitude also comes from the opposite vertex, but it's not going to make two congruent segments. Instead, it's going to make a right angle. And you've heard the word altitude before. We often use it as a height. You've probably seen this in area problems where we call this the height of the triangle. It's that straight up and down perpendicular right angle here, distance from the vertex to the opposite side. So this segment would be the altitude. All right, and we can have more than one, obviously, in a triangle. You can have them coming from any vertex. So here we'll say if a seg from a vertex makes right angles with the opposite side, then it is an altitude. So we can reverse it and say if a segment is an altitude, then it makes right angles with the opposite side. So again, both of them come from a vertex of a triangle. One makes congruent segments with the opposite side. One makes a right angle with the opposite side. All right, so first let's try these out in some proofs. These first couple are going to have to do with medians. So let's see how this connects. You're going to see all our ideas from congruent triangles are still going to tie in. So T congruent to Y, I'm going to mark that in my diagram. Angle SVZ congruent to angle SXZ. Let's find those. SVZ, that's this angle, and SXZ, I believe, is that angle. And then TV congruent to YX. TV, that's the segment, and YX is that segment. All right, I'm trying to prove, all right, let's mark this maybe in another color here. I need SZ to be the median to TY. So let's look at where that is. I need SZ to be the median to TY. Well, let's look above and see what median is again. Remember, a median is going to divide the opposite side into two congruent segments. So if I want SZ to be a median to TY, I'm going to need these two segments congruent right here, TZ and ZY. So I'm going to use congruent triangles to try to work on getting these two segments congruent. And when I look at my picture, I'm specifically kind of recognizing that these two green triangles seem pretty appealing. Right? And I hope you can see that too. They're pretty appealing because I already have two parts of them congruent. I have this side congruent to this side. I have this angle congruent to this angle. Right? If I could get one more piece, those triangles would be congruent, and then these bottom segments would be corresponding parts. So the question is, how do I finish these off, right? So far I have an angle and a side. So I know that could be angle side angle, or it could be side angle side. I'm looking at what I haven't used. What does this angle have to do with? Right? And again, this is one of those things you really need to see now in the diagram. They used to, in the given, list something like this, diagram. And when they did that, we were alerted to look for straight angles, which led us to supplementary. They're no longer going to put that word in the given, but hopefully you can see we have some straight angles in places, specifically right here at V and right here at X. So let's name those for a minute. I'm going to say angle SVT and angle SXY are straight angles. That's assumed. I hope you see where I'm going with this. I'm looking at supplementary angles. I hope you can see that this red one right here, I'm going to dot it, and this red one right here, this is supplementary to this double purple marked, right? Together they make this 180 degrees. This red one and this one marked with the purple double also make up that straight angle that I just mentioned. They make up 180 degrees. So the second step then is to state that supplementary. Angle SVZ, that's this purple one, is sup to this bottom one down here. I'll call it ZVT. And then this purple one, SXZ, is supplementary to this red one right here, which I'll call ZXY. And we know that is if angles add to 180, or you can say form a straight angle, then they are supplementary. All right, I'm going to put them in the box because I know I've got two of them. I look above, I know these two are congruent because that was in the given, these purple ones. So if the purple ones are congruent, I'm on the third step of that sequence. I can get angle ZVT congruent to angle ZXY. This is from the previous chapter. If angles are supplementary to congruent angles, then they are congruent. So now I'm going to go ahead and officially mark those in my diagram with a different mark. Now when I look at my green triangles, I hope you can see I have angle, side, angle. The side is included between the angles. Angle, side, angle. So I can get the triangles congruent. I will call it triangle TVZ, but then I have to be careful how I name it. If I call it TVZ, I think I have to call it YXZ, matching up appropriately. That was angle, side, angle. Now if you remember, looking back at what we wanted, we need a median, so we need these two segments congruent. Well, those are now corresponding parts. So now I can say TZ is congruent to ZY. I can say if triangles are congruent, then corresponding parts are congruent. Once those two segments are congruent, I have this case up here where I have these two congruent segments, so I know SZ is a median. So SZ median to TY, All right, think about which way we're going to say it. We're ending with medians, so that's got to be the top one. So I'm going to say if a segment divides the opposite side into two congruent segs, then it's a median. So it's sort of an extension of this whole congruent triangle corresponding parts. Let's look at another one on the next page. Okay, so here's another median problem. This time we're given a median. Instead of proving one, we're starting with it. FC is a median of triangle FBD. AB is congruent to DE. I'll mark that. Angle FCB is congruent to angle FCD. FCB, FCD, those are those two. That's all given. Let's take a look at this median. I didn't mark that. FC is a median in this triangle right here. Okay, so now we remember a median divides the opposite side into two congruent segments. So if FC is a median for this triangle, it's dividing this opposite side here. Here's the median. It's dividing this into two congruent parts. So this median is going to tell me that BC is congruent to CD. I can mark those. I'm starting with medians. So if a segment is the median, then it divides the opposite side into two congruent segs. So that's how I use that piece of given. All right, well now I kind of want to see what I need here. I'm trying to get, let's highlight it again. I need FC to bisect an angle. Well, where is that angle? That angle is AFE. So I need FC to bisect it. In order to get an angle bisector, I would have to have two congruent angles. I hope you agree that if this big orange angle is going to get cut in half, that means I would need this big angle here to the left congruent to this big angle here to the right. Well, I don't have that. I don't have any parts of those, so I'm thinking triangles. If I want this angle congruent to this angle, I'm going to look for triangles that contain those angles. So I think I'm going to go after this big triangle, because we have lots of triangles in the picture, and this big triangle over there. So again, I'm pursuing the green triangles because the green triangles will help me get this whole top left angle congruent to this whole top right angle, which is what I need to get this bisector. So looking at the green triangles, I have this angle. This is in the green triangles. I'm looking at the bottom, and you should recognize something from the last chapter. I believe I can add those segments. So I believe I can get AC congruent to CE by if congruent segments are added to congruent segs, then the sums are congruent. So now I can have this whole segment congruent to this whole segment. So as far as the green triangles go, I had that angle, and now I have this side. So I know I'm either working with angle side angle or side angle side, but I'm missing a piece. And I've used up all the given. So remember, if you are stuck, that means you're missing something you need to see in the diagram. If you look closely at these two green triangles, what you need to see is that they share this side right here. So don't forget to look for reflexive. This side FC is in both. So remember, we say FC congruent to FC. We say reflexive for that. That is the missing side, and the angle is between the two sides, so it is included. So then I can get my two triangles, my green ones. I'm going to call them FCA, and then I would have to call the other one FCE, congruent by side angle side. And then remember, I need the corresponding parts that will get me this orange bisected angle. So the corresponding parts are the top green angles. So that would be angle AFC congruent to angle EFC. That's if triangles congruent then corresponding parts congruent, because those are the ones then that are going to get me this bisector. So once I have these top angles congruent, I can then say ray FC bisects angle AFE, because if a ray divides an angle into two congruent angles, that's what I know from my corresponding parts, then it bisects the angle. That's what I'm saying here in line 7. So those were two examples, one where we had given a median and the previous one where we had to prove it. All right, we're going to shift gears now. We're going to talk about altitudes. So let's try these proofs. Here you see it's in the given. CD and BE are altitudes in triangle ABC, and we're also given AD congruent to AE. AD and AE. Let's mark that. All right, altitudes. If you look back, remember an altitude goes from a vertex and makes right angles. So CD is an altitude in this big triangle. So it comes from this vertex and it's going to make right angles right here. BE is an altitude. So over here it comes to the opposite side and it makes right angles. So I can definitely say that these are right angles, but I don't know which ones I want. So I'm going to go back and look at the prove here. I need DB and EC. So I need these. So I'm thinking I'm going to go after triangles. Let me mark them in green for you again. I think I can get these two top triangles congruent. Notice they are overlapping. They are sitting on top of each other. We're going to extend that idea in a couple of days. If I go after those two green triangles, right, so far I only have one part, right? If I look at that green triangle, I have this side. And if I look at this green triangle, I have this side. So I'm just going to list a side below there. But I think if I get the right angles, if I choose this right angle in this triangle, right, you can see it here, this right angle in this triangle, and if I cover that up and I choose this right angle in this triangle, I'll have a second part. So these are the ones I'm going to go after, these ones that I'm darkening, because they're in the green triangles. So let's call that angle AEB and angle ADC, whoops, are right angles. That comes from the altitude. Medians get us two congruent segments. Altitudes get us right angles. So if a segment is an altitude, then it makes right angles with the opposite side. All right, so now I've got those right angles. I can't yet list angle here because just because they're right angles, don't forget you have to say they're congruent. It's an easy step to miss. So I'm going to say if two angles are right angles, then they are congruent. Now I have the second part, so I can list angle. Well, that's still only two parts. So I know I'm heading towards side angle side or angle side angle. Right? If you look closely, those two green triangles share something. I believe they share this angle up at A. So look again, if you look at that triangle, right, you see angle A. And if you look at that triangle, you see angle A is also in it. So I'm going to use reflexive, but I'm going to use it for angles. And that might be the first time we've seen that, reflexive. So now I have that angle at the top. The side is in fact included between the two angles. So if I cover this up, if we just look at this one triangle, you can see I have an angle, a side, and an angle. So that is ASA. So triangle, if I call this first one BAE on the left, I'd have to call the second one CAD. That's by angle, side, angle. And then I realize I can't get DB. That's not a corresponding part. It's a piece of this side, but it's not an actual side itself, nor is EC. So I'm going to go after this whole side, and I hope you see where I'm heading, and this whole side by corresponding parts. So think for a minute, why am I choosing AB and AC? I'm going to say if triangle's congruent, then corresponding parts are congruent. Hopefully you see why I chose those now. If you look at this dotted segment and this segment, you should see overlapping, as you should see here with AC and AE. So overlapping means I can subtract to get DB congruent to EC. If congruent segs are subtracted from congruent segs, then the differences are congruent. So we're really stretching you here. These last 3 proofs have been tough ones. We're really using a lot of ideas. We're getting congruent triangles. We're using corresponding parts. And then we're taking it, a step or 2 further. So if you need to listen to these more than once, feel free to hit rewind. Okay, example 4 here. I think this is our last proof example. We have angle 1 congruent to angle 2. We have HP congruent to MJ. Let's mark those. HP, these little segments, MJ. And then I have NP is an altitude of triangle NHJ. And OM is an altitude for triangle OHJ. So again, I'm given altitudes. All right, let's see where those are. NP is an altitude for this big triangle, which means I should be able to get some right angles there. And OM is an altitude for OHJ, so where it hits the other side, I should be able to get right angles. The question is, what right angles do I want? Well, looking ahead, I need to get, let's highlight it here, I need to get OM and I need to get NP. All right, so let's think ahead to triangles, right? Well, I think I might want these triangles because I know this side, but that doesn't really help me because I have this angle 1 and angle 2. So I actually think I'm going to use the other triangles. I'm going to use these 2 bigger triangles, so it's a little easy to get misled. And while I've marked those, you can see that I like angle 1 and angle 2, so I have an angle. You can see I can choose this right angle right here now from the altitude, and this one from the altitude. So let's write that first, and then we're going to come back to what we're going to do with those segments. So this would be angle NPJ, and angle OMH, I'm going to call it, are right angles if a segment is an altitude, then it makes right angles with the opposite side. I'm going to go ahead and get those angles congruent. I don't want to forget that step. Angle NPJ is congruent to angle OMH. If 2 angles are right angles, then they are congruent. Now I have that second angle piece. Well, I know the only triangle congruence I have with 2 angles has to have a side in between. Well, think about this triangle right here, right? If I have this angle and I have this angle down here too, the side in between has to be this PJ. And if I have angle 1 and this right angle, the side in between has to be HM. So the question is, how do you use these 2 little segments to get HM congruent to PJ? Do you remember what we do when we have 2 segments and a space in between? We can add, so that is HM congruent to PJ. That's if the same segment is added to congruent segs, then the sums are congruent. That gets me HM and PJ. That gets me the side. Now I have the side between the angles, so I can say triangle if I call it HMO. Careful, I'd have to call it what? JPN to match them upright. That would be, whoops, angle, side, angle. And now I believe I can say OM and NP are corresponding parts. So if triangles are congruent, then corresponding parts are congruent. All right, those were some tough ones, so don't panic if you're finding those hard. This is kind of our first really many steps past the congruent triangle piece. All right, let's hit our last couple of targets. So here we just want to make sure we can recognize the difference between a median and an altitude. Right, so I'll do them in two different colors here. I'm going to make my medians all in green, and I want to go from C to AB. So a median is two congruent segs. So I'm going from C to the opposite side to make two congruent segments. So that would be a median. From C across to the opposite side to make two congruent segments. From C across to make two congruent segments. Those would all be medians. Those are in green. Remember, altitudes make right angles. So I'm going from the same point C, but now I have to drop straight down and I have to make a right angle. C, well, I'm a little perplexed here how I'm going to get from C to AB and make a right angle. So this is one in an obtuse triangle. Your altitude actually lies outside the triangle. So I'd have to kind of extend this side, and then I would drop C down, and that would make a right angle. So that's an interesting one. That only happens on obtuse triangles. The altitude is outside. This last one is interesting too. I hope you can realize this looks like kind of a triangle where these two sides are the same and this one isn't. So if I go to drop an altitude, looks like it's almost going to be about the same segment. So sometimes an altitude and a median can be the same. That's a possibility. Sometimes they're outside the triangle, and sometimes they're different, and that's what we had worked with before. All right, our last little target, I told you this was a pretty easy one. It was this one on auxiliary lines. It says, if you need to connect 2 points in a diagram, you may simply state draw as a statement in your proof. And for the reason, you can just say auxiliary line. And it's based off this postulate that says 2 points determine a line, array, or a segment. So I hope when you look at this diagram, it gives us G as the midpoint of FH. We can darken that here. And we get EF congruent to EH. I hope when you look at this, you realize we're missing a line. I'd really like to connect EG. So I'm going to do it, but that's what this is telling you to do. We're going to use this draw EG. So I'm drawing the segment in the diagram, and all I put for my reason here is just auxiliary line, and you can even abbreviate it, auxiliary line. So now that's in my diagram. I'm trying to prove angle 1 congruent to angle 2. I think this has something to do with congruent triangles, right? Because I see two triangles that look a lot the same. Think about midpoint. Midpoint should tell me that these two segments are congruent. So I can get HG congruent to GF. That's my definition. If a point is the midpoint, then it divides it into two congruent segs. These triangles are looking pretty close. Hopefully you see in the diagram that they share this side. So I can get EG congruent to EG. That's reflexive. And now it should be obvious, I think, that those two triangles can be congruent by side, side, side. Whoops, I forgot my triangle marker. EGF, side, side, side. But the question is, how is that going to help me get 1 and 2? What corresponding parts of these triangles are important to angles 1 and 2? Hopefully you realize it's these guys right here. this angle by H, and this angle right here by F. So these are the ones I'm choosing as my corresponding parts. So let's say that. I can say angle EHG is congruent to angle EFG by if triangle's congruent, then corresponding parts are congruent. Right? I hope you're seeing the connection. What's the connection? They are supplementary to 1 and 2. See how they make this 180 and this 180? So I got to go back and say I have straight angles here. So I'm going to say, oh, I need some letters out here. Let's call this X and let's call this Y. Sorry about that. I'm going to say angle XHG and angle GFY are straight angles. That would be assumed. That's step 1. Now I'm going to say supplementary, right? I know angle 1 is sup to this corresponding part angle, which was angle EHG, and I can say angle 2 is supplementary to this corresponding part, which was angle EFG. We know that's if angles add to 180, then sup. All right, same old stuff we're doing here. We box them up. I know these two are congruent. That's these. Therefore, angle 1 is congruent to angle 2. We'll say it one more time. If angles sup to congruent angles, then congruent. So again, this 3-step supplementary process, it really appears a lot. You need to be able to see it in diagrams to see, ooh, I have supplementary angles and 2 of them are congruent, so I know I can use it to get the other 2 congruent.